Hello, everybody. Thank you very much for joining. Apologies for the slightly delayed start. I will be your host for today's session. And before we introduce the speaker and ask the speaker to introduce herself, just go through a couple of elements of housekeeping. So if you do feel comfortable, it'd be great if you could turn on your cameras. Really helps our speakers understand who they're speaking to and makes it feel a bit more human in this virtual world. If you could post questions in the Hoover platform, the Q&A function, I will pick them out at the end. The ones that bubble to the top, I'll cover first. And please don't forget to tweet and tag at RabbitMQ Summit. Helps us get the word out there around this conference. Without further ado, I'm going to hand over to Maryna to introduce herself.
So, hello everybody, good evening and good morning. My name is Maryna Zhygadlo. I'm a software developer. I have been working for Diebold Nixdorf. So it's an international financial and retail technology company. So almost 6 years ago, I joined the company to work on a product of new generation. So namely, it's a cloud-based point of sales for fuel stations, POS. And today, actually, I will share my experience, of using RabbitMQ for the some use cases, examples, and for the system that I have developed. So, may I then continue with the presentation, right? So no questions?
Yes, absolutely. Yep, please go ahead. Thank you.
So, great. So just a bit of delay. Second. Okay, I'll introduce myself. That's me. So as I already mentioned, so I work in the domain of the retail, and I've been fortunate to be in the group of the innovators in our company who have transformed a proof of concept into a production rollout. And since little bit then 3 years, the product has been running on production and actually being actively used by users. So this is actually the picture of the early releases of the core product of the company I worked for. It was done more than 20 years ago. And actually, me as a developer, I was actually doing this first step into cloud transformation of the product. So generally speaking, in terms of software architecture, the main goal, let's say, was to create a distributed system with event-driven architecture, and actually it was meant to be a replacement of the monolithic applications. And after long discussions, research, and analysis, RabbitMQ was chosen as a message broker of cloud POS and retail applications. So so from the beginning, so it was actually quite challenging, let's say, to bring this innovation to life, because we faced plenty of challenges, and I will show actually what were those challenges and how actually we managed to solve them. So, as I already mentioned, that the core product has been developed a long time ago, and of course, so obviously, it required a lot of efforts and time to replace the full functionality that has been developed long time ago. That's why let's say we started with the baby steps, with a small idea to create a lightweighted microservice that could be deployed side by side with the big legacy monolithic, let's say. No, it's not legacy, but it's still used, but let's say we call it like that. So it should be deployed side by side with the monolithic app, which was still running and actively used, and it should interact with this application, let's say, send data and grab data, needed data, and then actually process this data, aggregate, and somehow transfer it to the cloud. So I will tell in more details what actually, it was doing. So yeah. So the idea was to develop something, so the solution that could be easily integrated, incorporated with the existing solution, which was used actually by the customers, and it would expose a functionality in the shape of public API. So actually, so first challenge was to take about the compatibility with the legacy monolithic applications running on premises. So besides of that, so our fuel stations, our edge devices, they actually were in distant places, so we needed to take into account that fact that we had limited access, and we needed to think about actually failover scenarios, deployment strategies, and stuff, because we were quite limited in possibilities. Also, latency of our system played a crucial role, because our let's say solution needed to be responsive, because it had an impact on the customer experience. So actually we needed to take into account this fact thoroughly. Also, as I mentioned, so let's say this monolithic big application, it was producing and interacting with a bunch of big bunch of the data, and we needed actually map it, aggregate, and filter it, and make sure that we are let's say sending to the cloud only the needed data, not any extra data. So actually we took this fact also on this early stages of the projecting, let's say, of the system. And the final, let's say, so it was not like a challenge, but the final usage and the final task was that our software should be integrated with the third parties, and actually and the idea was that this API that actually had to give a possibility to interact with any edge of the, let's say, on premises on the system. Sorry, I have a question. So should I click the button admit, or you will do that to people? Okay, so
I'll do that, no problem.
Great. Okay, so these were the challenges that were successfully solved. And let me tell about the use cases. So like generally speaking, we needed to accumulate data from edge devices. So actually, so it looks like that. So actually the messages were sent from the edges to the cloud. And so sorry, here's this panel, but so can you see actually this right part? So we have this third-party applications that actually that they needed to interact with the API, and then actually let's say end user was so customers that were paying for the fuel on the stations. So actually, so this is this, let's say, simple way to accumulate the data. And for instance, we needed to send fuel transactions. So actually, just imagine that, let's say, in the scope of some country, in the real time, they are performing a lot of filling of the cars, and all this data should be transferred to the cloud. Besides of that, we also collected, so actually we needed to make sure that our edge devices, they are, so that they are about their operability, about their state, that it's possible actually, to pay via mobile phone for the fuel. So actually, so this is briefly about the one direction of the data that was accumulated. And the second one, we needed to receive the data on the edges. So let's say, generally speaking, some instructions from the customer who were clicking his or her mobile phone, and actually, so this, let's say, activities should be sent through the cloud, then routed to a proper edges. So so this is actually briefly the use cases, and about the, let's say, the data that was routed to edges. It was some simple activities like adding to the check some products like fuel products and other products, and also fulfilling the payment. So what is actually under the hood? So actually, I prepared this slide, so it's like abstraction of the services, of the set of the services. So this part, upper part, is actually set of microservices responsible for some really the core functionality of the system, because the system is quite huge. And I will be speaking only about this functionality related to the let's say this payment of the fuel. So basically, we needed to have RabbitMQ in the cloud, because the bunch of the services were communicating through RabbitMQ. And also, we had it also services running on the premises. And also they were also communicating through RabbitMQ with each other. And we needed some data to be transferred from cloud to the edge, and from edge to the cloud. So for that, we were actually using federation and fanout exchanges. So I will tell more details. So this is actually, so sorry, can you see the full picture? Because I have this panel with the...
Yes, yeah, we can see the whole slide from producer to consumer.
Yeah, so actually, great. So as a mechanism to transfer data from the cloud to edge, we used federation in both directions. So actually, so the producers, so actually it were normal services, deployed on the cloud, and they were actually, for instance, in the previous slide, this activities sent from the mobile phone, they were produced and published to the fanout exchanges. Then we actually federated these fanout exchanges. So actually, each fanout exchange was responsible for the certain edge. So basically, and these fanout exchanges, then they were federated to the local, so the RabbitMQ on premises. And then actually we had this consumers. So consumers actually, so it's abstract name of the lightweight microservice that was interacting with monolithic app running on premises. And actually we had also bidirectional communication. So also we had producers on premises and consumers on the cloud. So it was like let's say our first meeting with RabbitMQ, and we actually managed to to develop this, to make it work. Actually, so we started to test, made the load test. So actually, we have scaled our system with the 100 edge devices. Everything was okay. And then we actually scaled up to 300. And then actually we had troubles with RabbitMQ. So actually on cloud, we had RabbitMQ cluster, and we had a lot of connections, because actually each federation link from edge device for certain message type created connection. And the problem was that, the amount of connections were quite big. So it was not that big, but somehow system was not managing, these connections. And there was some magic number actually going after the number system. So the RabbitMQ cluster was crashing. And we started to think about how it's possible to optimize our solution, and what we could do better to make the solution more elegant. And actually we replaced, replaced fanout exchanges with direct exchanges. So actually it gave us, let's say, so each direct exchange was represented, let's say, exchange for edge device, and it was routing to different queues, and each queue was responsible for some certain message type. So basically, the outcome of this approach was that we had amount of connections equal to the amount of edges, and it was quite good solution, quite performant, and we actually succeeded to eliminate a couple of times less amount of connections. So So we have right now, let's say, 2 production environments. First is running still with the fan-out exchanges, and the second one is running with direct exchanges and federation. And as well, we also prepared, let's say, even more optimized solution. Because bidirectional federations, they actually were duplicating connections. So basically, if we need to transfer data from site to cloud, we had actually amount of connections equal to edges, and vice versa, it was multiple too. And then actually we also optimized the solution having direct exchanges with shovel, which gave us benefit to eliminate so these doubled connections on the cloud. So only, let's say, the most optimal solution is having connections and direct exchanges equal to edge devices. So yeah, a couple of words about the system in numbers, what we have right now. So we have 5 nodes cluster, which is running on cloud using Docker Swarm. So we have 700 edges, edge devices for, let's say, one environment. We have 4 and 5K connections. So the message rate is, let's say, average is 15 message per second. So also this number is varies because we have rush hours. We have, let's say, more let's say, quiet hours when we don't have traffic. So the latency of our system, the average actual latency is 536 milliseconds. So actually this is the request which comes to edge device and goes back. Also we have quite small message payload, so we are operating with a pretty quite compact, let's say, small messages, so they are up to 800 bytes. So we have not so much 1.5K queues, 4K exchanges. And so this is actually, let's say, overall, so it's not so huge system, but so it's according to the sizes, so I know it's middle, I would say, but it was quite challenging, I would say, because it was, let's say, our first experience as developers to work with this new concept. And right now, the system is successfully running. It's quite stable. We had, let's say, after rollout, we had actually troubles with let's say, tuning the federation connections, federation upstreams. So actually the problem was when, for some reason, connection from site, from edges to cloud was dropped, and then all edges, so actually all RabbitMQ federation clients started to establish connection, and somehow this simultaneous, let's say, so the connections were establishing simultaneously, and somehow it also was killing the RabbitMQ cluster. That's why we were in the upstream federation upstreams, there were reconnection parameter, and the idea was actually to have it random for each edge device. So actually it solved the problem that connections were established not simultaneously, but let's say in some randomized manner. So also we use HA policies, so durable queues. So and also we use expiration policy for our data which is coming from cloud and from the edges, because the data which is older than half an hour is not relevant, and actually it should be deleted, because the system doesn't operate, and doesn't make sense to operate with such data. So briefly that's it, I would say. So how much time do I have? Because I also prepared some code. And does it make sense to answer then questions, or maybe to show, because I have prepared also, let's say, similar configuration, some examples.
So you've got about 15 minutes left, including time for questions. So if you, and generally we're taking about 10 minutes for Q&A. So you've got another 5 minutes if there's something else you'd like to talk about.
Okay, just a second, maybe I will show.
And if anybody wants to ask a question, please drop it in the Hoover platform.
Yeah, maybe actually the questions will be somehow interacted. yeah, connected with the explanations that I have prepared with the RabbitMQ. So you're welcome, please.
So sorry, would you like to go through the questions now then?
So I don't mind if people, if there are some questions, I am ready to answer.
Okay. Let's cover those next. So if you want to go ahead and demonstrate what you're hoping to show now, that would be great.
Okay, so yeah, so I have prepared, let's say, yeah, so simple configuration, what I have talked about a little bit earlier. I have prepared, let's say, so this setup, which is yeah, on this picture. So let's assume. So this is actually my cloud cluster. Yeah, so this is how it looks like. So cloud cluster has fan-out exchanges. So actually, this is the, let's say, first implementation what we have developed as a proof of concept. So basically, this is the edge one. It's like a unique identifier for the edge device, and then actually the prefix is let's say the functionality, or yeah. So basically, this is the type of the message which is going to be transferred to the edge device. So basically, we have per each edge, we have three types. Like first, simple functionality: add transaction, remove transaction. So add transaction to check, remove transaction from check, and finalize transaction. And also, so as example, I have prepared also, yeah, the second edge. So there could be plenty of these edges. And also, I have prepared another instance of the RabbitMQ, and so just as a purpose to demonstrate, I have created here two virtual hosts. So each virtual host is representing a separate device, a separate edge device. And I have created consumers. So actually, consumers are consuming from the RabbitMQ, from this virtual hosts here. And so let's have a look what actually, yeah, have been created. So on this local RabbitMQ running on premises, we have, yeah, so we have actually fan-out exchanges, and fan-out exchanges are, yeah, they are binned to the queues. So actually, I used .NET Master-Z framework to create the code, and actually the code does this configuration, and yeah, does this simple, let's say, representation how it's working. So actually, I also can share this code I have posted on GitHub. So from the configuration point of view, I have created per each virtual host, I have created federation upstream. So yeah, it's simple one. So it actually it connects to the cloud RabbitMQ cluster, and yeah, it has some parameters, some simple like heartbeat, also connection timeout, expiration, and message detail. So actually, to, let's say, make sure that when the data, when messages are stale, so we are not interested anymore in that. And we have policies. So each edge device has policies. So basically, we will receive, so we will federate all the exchanges starting from the unique name of the edge device. Yeah, and let's have a look on the connections right now, what we have. So we are more interested in what is going on the cluster side, on the cloud side. So we will have situation that per each fan-out exchange, we will have a connection. So 3 multiple, because we have 2 edges, we will have 6 connections. So the math is quite simple, yeah. And another example, actually, we are replacing. So we also have the same situation, 2 edge devices, but instead of fan-out exchanges, we are using direct exchanges. And so basically, here's this cluster. And actually, instead of that, we will have only one connection. So actually, this is the federation link, which is federating the direct exchange, yeah, to the local RabbitMQ. Yeah, so this is, let's say, simple example of that. So yeah. So that's it. What I have planned to tell.
Amazing. Thank you very much indeed, Maryna. We do have some questions. Is Bertus Botha on the call? And would you like to unmute yourself and ask your question?
Hi, can you hear me?
Yes.
Yes, I'd just like to ask Maryna, when you went about converting the legacy system files to messages to be published on these queues, what was your methodology to minimize? Because usually those files are quite large, like in batch mode, contains a lot of data. How did you go about to make them like small enough to be used in a message broker system?
Yeah, so I will explain. So just imagine that. So locally, we have let's say system, developed in using, let's say, Microsoft Stack. Yeah, so we have C#, some .NET 3.5 for instance. Also, we have a SQL database, and basically these lightweight services. So actually, they had different functionality, different approaches how to interact with this legacy data. So one services, they were, let's say, reading, data from the databases. Yeah, and for instance, we were interested in some certain fields, some certain data. So the services, they were reading information from database, and then they were converting this data to messages, and then they published to the message bus. The second way was that this, let's say, microservices, they were using WebSockets. So actually they communicated with this monolithic applications, with WebSockets, and also they have they have mapped WebSocket events to message bus events. So it's, let's say, sounds maybe complicated, but in reality, just, let's say, the way how to package and what is needed from the, let's say, business perspective, let's say.
All right, thank you.
Thank you. And Johan, do we have Johan here? Would you like to unmute? Hello.
One maybe simple question: are you using publisher confirms? And for that 5-node cluster, are you using quorum queues? And what's the size of the quorum that you require if that's the case?
Sorry, the last sentence. Can you please repeat?
Yes. So first part is, are you using publisher confirms, and second part is what are you using quorum queues?
Yes, we're using publish and confirm. So basically, I don't know if you're familiar with sagas. So it's state machines, which are a part of the, which introduced by Masterzit. So it's like combination of publish and confirm pattern, so request response plus sagas, and so the services are stateless. So basically, this states of the state machines of sagas are stored in the cache, and this match of, let's say, a request sent by cloud and the response received by edge. So the match is being done on the cloud with the state machine. So something like that. So did I answer your question? I hope.
Oh, that's fine. Yeah, thank you.
Thanks, Johan. And Terence, is Terence on the call?
I am. Afternoon.
Hello. Would you like to ask your question, please?
Sure. So I've seen in production shovels do some weird things after a server reboot in particular, where they'll get stuck in a starting state. So I was wondering if you were doing anything special to monitor the shovels, confirm that they're in a proper running and connected state.
Yeah, so let's say we had such, let's say, similar experience with federations. So we had a lot of, let's say, connections which were not dropped, and the amount of connections were growing. And like a tweak on the first stages, we have implemented, let's say, some process which was monitoring cluster checking these connections, yeah, and was dropping them if they were actually growing and they were not doing anything related, let's say, to the business logic, to the edge devices. And regarding about the shovel, so we have, as I mentioned, so we don't have it on production, but we have also a health check system. So it's also, so I'm not aware about the details, but I know that so it's planned to have at least something like that to check and to make sure that system is performant and system is working smoothly and everything is okay. So it's also an important part because besides of the business logic, we also had, let's say, a big system of health checks, monitoring, and all this stuff. Because it was, let's say, it had also a lot of impact on the overall system.
Okay, thank you. Maryna, I had a question, which was in terms of the connections between the edge devices and the cloud. Did you run into, or how did you deal with the potential of running into a slow consumer or a broken network connection that might cause messages to build up?
Yeah, so actually also we had this problem, and so we have introduced retry logic on the cloud. So actually we developed, let's say, the business logic that we had a specific error codes to understand, let's say, if the response is not successful because of network problems, between cloud and site, or because of the legacy system is not working. And actually we developed, let's say, different response codes, different retry logic, and also introduced this logic to the client. And client was, so this third party, let's say, third party companies, they knew in what cases it makes sense to retry and in what cases it doesn't make sense to retry. And besides of that, so for instance, if so the situation is that, for instance, I don't know, something, so we had also such situation like we had problems with OpenVPN, and system was not working, and the support was checking what is wrong. So after that, we have introduced logic, for instance, so it's like schedule a task. So for instance, if it's not possible to do some operations immediately, so like some, I don't know, finalization of transactions, something like that. This functionality should be then finalized when the system is back.
Okay, and then did you find that you were running out of storage ever on any of the?
Yes.
And so was that one of the scheduler tasks to clear that out?
Yeah, so at first stages there were, let's say, production crashes quite often, but then we actually covered and handled all the potential problems, and we detected, eliminated them, and actually so after, I must say that, like a couple of months, the system was running quite smoothly and really stable, so without any issues. And also this, let's say, growing of the memory also was detected during the load test. So this is going through the watermark and all the stuff. So but it was quite interesting, I must say, that this load testing of RabbitMQ, in this distributed setup, quite interesting task.
Excellent. Yeah, great to hear how you handled it. So thank you very much. We're just about out of time now. Thank you everybody for attending. Thank you to Maryna for presenting, and we'll see you on the next session.
Thank you for joining. Yeah.